Good morning, and welcome back to the Our Innovation Center InventX demonstration series. So just a few housekeeping rules. Make sure you're on mute. We have a chat and QA function. We currently do not have the raise hand function. So any questions you want to ask, please put them in the Q&A and we'll get to them during our intervals. I'm Jordan Strachan, the CAD technician here at the Our Innovation Center. And I'll be joined here today by Dr. Ellis Marshall, who will be going through different resin technologies in 3D printing.
So thank you very much, Jordan. Thank you very much for the introduction. Welcome to the Our Innovation Center. Today we're talking about 3D printing with resin. That means multiple things. So we're going to go through a few technologies, and I've also thrown in a bit of 4D printing for good luck, as it was mentioned on LinkedIn and Twitter. So I thought I'd talk to you all about that today. So we're going to start off with a very simple technology. It's called SLA, so stereolithography. So here we actually use the Formlabs 3D printer to utilize this technology. So I want to go over first, though, a slight bit of history about SLA 3D printing. It was actually the first type of 3D printing invented back in 1983 by a chap called Chuck Hull. Unfortunately, he's in Colorado, USA, so no link to Hull here. But it's good to know that Hull is out there. So that was 1983, was the first type of 3D printing ever utilized, and that was the first patent. And so from then, it's actually accelerated and it's grown rapidly, especially from 2000s to 2010, and now 2010 to 2020. It was a very slow pickup, though, in that initial period of 1983 to 2000. And technologies such as the FDM 3D printing that we mentioned last week, FFF, and then you've got technologies such as laser sintering, material extrusion, laser melting, electron beam melting. These are a lot more industrial processes that are utilized and have a greater cost as well to them. But they're currently being used in industry all over the world. So it's nice to see this technology has grown from 1983 up to the present day and is rapidly becoming a lot more popular. So here's a basic sketch of an SLA 3D printer. I just wanted to explain how it worked. So what it does, if you can just see on here. So this is the inside of an SLA 3D printer. You'll have to bear with me. This is a bit sort of sketchy that I've done here. But the green light is a laser. So SLA technology utilizes a laser of a certain wavelength. And what it does is that laser bounces off a mirror into the resin that we were talking about. So this is that viscous material that reacts to light. And so to get the correct part you're printing, you shine the laser at the build plate, which is in the resin, and it cures one layer at a time. Then it will lift up, come back down, do a second layer. So if you imagine FDM, that's upside down. So you have your build plate and it builds on top, like we discussed last week. Whereas this one has the build plate and it builds from underneath, using a different technology as well. It's quite a clever bit of kit, and while it is simple in principle, it does get more and more complicated, especially as the years have gone on. And we're getting to the point now where we can actually do continuous SLA 3D printing, and that's called a different technology. That's called CLIP, C-L-I-P, Continuous Liquid Interface Processing. And we'll come on to that a bit later as well. I mentioned it in the 4D printing side of it. And that's a lot faster technique. Usually when you're SLA 3D printing, you build a layer, you have to wait 10, 20 seconds to do your next layer, same again. That builds up over 200 layers to a massive time. So if you can utilize a technology that doesn't have that up movement, it's actually a lot faster. So it reduces your time down. But yeah, this is the basics of SLA. So it's a laser going into a mirror, going into the polymer and curing it. It's called photo curing because it utilizes a certain wavelength of light to cure, and it reacts to a certain wavelength. So that's the basics of SLA, and we'll go back to our Formlabs 3D printer that I have sketched up in CAD. So just a plug here for our CAD session as well. So we're currently undertaking with Jordan CAD webinars. Last week was CAD for 3D printing. And then we've got one this week and then next week as well. So please do join in. We'll be doing all sorts of cool stuff with him. So please do join in for that. So here's the lovely Jordan. He's just demonstrating more 3D printing devices we have here. So SLA 3D printing is the box in the middle that we can see in a second. And you can also see it behind me in my background. So this is the one that does all the work. Then after printing, you have to do post-processing to get all the benefits out of your product. This post-processing is washing, it's washing with alcohol, and it's curing with more UV light. But what is the material that you're utilizing? It's if you can see this picture, it's this orange liquid in this one. And you can see the Eiffel Tower just emerging up out of it. This is a very basic setup from a good decade ago. And you can just see it raising up out of this vat of liquid, almost like a sci-fi movie. The properties of this material that you can get out of it as well is, well, for one, it's waterproof. Water just doesn't penetrate into the material. It's a polymer, it's a plastic. It's not like PLA that will take up water. It is hydrophobic by nature. It's a very durable material. You can even go as far as buying durable resins to utilize that have a greater durability built into them. You can get resins that are flexible, that give you flexible qualities. So in this, I was using an example, we 3D printed a heart out of a flexible resin. You can actually hold it in your hands and clench it and make it sort of beat almost like a heart. You could probably hook up a vacuum to it as well and make it go in and out as well. So very flexible materials. You can also get elastic materials. You can get materials that are high impact. So if you've got an application maybe that requires a high impact material, SLA 3D printing can do that. You can get colored materials. And now some manufacturers are going so far as you can generate your own color. So if you've got a brand out there that has a certain color behind it, so a certain shade of purple, green, pink, you can actually color your material to match. So you can do loads of 3D printing in that color for your company. So that is also possible. And then we've also got rigid 3D printing as well. So rigid material, again, suitable for applications needing that hard impact strength. There's a lot of applications out there for SLA 3D printing. There really is no limit. And again, you can compare this to traditional manufacturing. So traditional manufacturing, you'd have to get a block of material and tool away the excess and go inside and tool away the excess as well inside to get your material. And there's a lot of waste, whereas SLA 3D printing, you've got your resin tray at the bottom and you're making your material emerge out of it. So there's not a lot of waste. You can reutilize most of the time the resin in there, as long as it hasn't come into contact with daylight or another source of UV light. So one important thing is when storing this material is to keep it away from daylight. And that's why you see the Formlabs 3D printer in an orange box. It just keeps away a certain wavelength. So just carry on there. So I want to just show you two materials here. So on the left, these are both SLA 3D printed. So on the left, this is the highest resolution, or well, lowest resolution really. This is, I can't remember, is it 200 micron, 500, no, 50 micron, there we go, that's 50 micron. You can actually see the layers in it. And then on the other side, we've got a really fine one and you can't even see the layers. I'm just going to carry on there and you'll go to this one. So if you can see the layers in this, so this is how it builds it, this is how it processes it. So we can go from this resolution And this is quite a fast print. This will probably take less than an hour to do. And you can see the surface finish isn't great, but it's done in a rapid amount of time. And you'd probably call this a draft product. Whereas if you did it nice and slow, this is probably many, many hundreds of layers to make each section here. This resolution is tiny. And this is done on the same printer. And I'm not even sure if you looked hard on this picture, if you could see the layers, but you can see the texture as well as beautiful finish on it. And that's all from one 3D printer. So again, if you've got an application that needs a quick draft, we can do it on SLA, nice and fast. We can also do these finer detailed prints as well. So here's just a little aura tag that I've done in a nice clear resin. So here we're getting onto a bit of a case study. This is a company we've actually been working with. On the right is their device, their metal tool device that they give us. And then going through the line here, we'll actually see different 3D printed materials. So right next to it is the clear one printed from the SLA printer. Next to it is our Mark Forged, our FFF 3D printer. And the last one is our metal 3D printer, which we'll talk about next week. So these are all from one design, one file, but many different materials. So here we are comparing the metal to the resin. It's exactly the same shape, but you can actually see through it, which is very important if you're doing something like a demonstration. You can actually see liquid flowing through the material if you needed to. And it was also printed in a few hours, whereas the metal tool would take a long time to print. We also did a few design iterations with this company as well. So we actually redesigned or looked at redesigning the shape to complement 3D printing. So the original shape is on the left from the metal tooling. And you can see it's actually quite opaque. And on the right-hand side, we actually have a more transparent material with a different design and a different locking system, which can be achieved through 3D printing because there's no need to get inside with the tooling to change anything around. So it's quite nice to see the two variables there. And what we've done is, well, we've changed our post-processing technique to vary the amount of light that goes in there and how much you can actually see through the material itself. So here's a nice close-up. And if we ran blue liquid through it, for instance, you could see it flow through. It's a very nice design with an intricate lock inside. This is another example of 3D printing, but this actually has a wider application, and this application is for medical applications. So this is for, well, I can't really say what it's for, but it's for a medical device. On the left-hand side is the medical grade resin. So this is resin that can go into an autoclave that can get sterilized in traditional methods, either in an oven or an autoclave itself, or washed with sterilizer. It can be sterilized in any way like a normal device. So it can go in with everything else medical device wise and sterilized, which is great. So if there's any businesses out there that are looking at medical devices that need to go into batch production, so if you're a client and you're looking to do a medical test and you need a device for a run of 100, I would recommend SLA 3D printing and this medical grade resin to do it. Because you'll always get advice back from your medical results saying that a design needs to be changed or this needs to be changed. Maybe it needs to be bigger, smaller, depending on the patient. And that's something that's so easy to do if you've 3D printed it, and at that stage, it's a lot harder to correct if you've gone through the tooling process and generated it that way. So yeah, on the right is the medical one, on the left is the normal one. So here, we're just going to open up for a poll and just check the Q&A. So just invite Jordan back and we'll just get the first poll up. So what experience of SLA do you currently have? Is it none, a little, a lot? So next on the journey as well, we'll be looking at slicing and how to slice SLA 3D prints, how we do it, and examples of support systems that are behind it as well. So the actual supports that are generated.
So I have a few questions here.
So first question is, what kind of difference are we looking at for print speeds between SLA printers and more traditional printers, such as the filament printers we went through last week?
Yeah, that's a good question. The print speeds. So it depends on the resolution. So if you go for that draft resolution that we were looking at, I would say it's comparable with FDM 3D printing. But if you're going for that very, very fine resolution, you're doing a lot more layers. You're probably doing, say, 1,000 layers of material, whereas in an FDM print, you're probably only doing 400, 500. So yes, high resolution will take a lot longer, but comparably draft for draft is about the same.
And then we have a question about the medical resin. So is this resin safe to be used inside the body, or is this just for outside applications?
Yeah, definitely just outside applications. I wouldn't say ingest any, definitely not. It could be used in surgical applications because it can be that level of sterilization, but I definitely wouldn't use it for bones or hip replacements or anything like that. So yeah. There we go. Brilliant. So thank you very much for everyone filling out the poll. It's great to see we've actually got so many people that don't know what SLA is and they've tuned in to find out more. So hopefully from the little brief introduction I've done there, you can understand SLA and how it can be used, or why it can be used, what properties it has, why you'd want to use it as well, and applications as to why. So we're just going to go into the bit of the background now of SLA 3D printing, so I'll just carry on. So here we're actually going to go through slicing a print for SLA 3D printing. So this is actually one of Jordan's CAD models that he will show you on his webinar. So this is just rotating it around, having a look. You can change what orientation you have the device. So there is different ones depending on how you want to print it. We always print it at an angle because you get a better build quality for it. And then what you do then is generate supports. So supports are required to make sure, so if you've got a print at a slant, you need to make sure that the last bit of the print will get printed fine. So you need to put supports underneath it to support the actual print. So this is what's happening here. We're just choosing a resolution here. So you can see these little, well, it's just below my finger. You can see the little struts are going down. I've got a video just after this showing you all the supports around it, actually 3D printed. So yeah, these are all the supports that are around it, and you have to take them off after printing, but they are required to 3D print the device. You could potentially print it flat on the actual build base itself, but you run into a whole host of problems. So we actually advise printing it at an angle. So I'll just play that. So up next, we're just sending it to the 3D printer as well. So yeah, it's all on Wi-Fi as well. So we don't have to actually move anywhere. We can just do it all on the Wi-Fi. So yeah, here is the actual print. So you can see the supports around it that are still on. They're just coming back into focus. You can see all these lovely supports just holding it. It's not many supports on it. And it's done at a strange angle as well. So that's called overhang, where anything is past a 45-degree level. It has trouble getting built. So we've got a small one here, and I think we go to a large one next. So this has got a lot more supports, and you can choose the density of supports. But that's generally down to the technical support rather than the actual client. The client is just interested in the product itself after it's been post-processed, washed, dried, and then sanded down if needed to get rid of any bits and bobs stuck on there. So another thing, this has actually been SLA 3D printed. This was actually on a photocentric device. which is another type of 3D printing, but I haven't gone into that today. But you can't actually see the layer lines on this as well. It's so intricate and so fine that you actually struggle to see it. But inside there's a staircase as well, and I go up and do an overhead shot. It's a DNA sequence and a staircase just inside. So you can't see it too well there, but you can see the staircase. You can see its little turrets. There's a little DNA in there as well. So yeah, that is the basics of SLA 3D printing. So here is the Formlabs in the middle, the wash, and the dry station. So we're just going to go into a different type of 3D printing now. I'm just going to hit on this. This is another service that the University of Hull offer. This is the use of the J750. So this is a very high-end 3D printer used for multiple colors and multiple applications as well. So it can actually 3D print a device like that with moving parts and moving functions and different textures and different materials and different blends of color. It's a very high-end product finish. So if you're looking for that very, very high-end product finish to take to an investor to take somewhere, then I would recommend this 3D printer. And the way it's better is, I've just taken this from the Stratasys website. The way it's better is that you can actually design the file and send it to the printer. There's no need to color it afterwards. There's no need to paint it. There's no painstaking coloration afterwards of fiddling around. So say if you 3D printed a shoe, you don't have to go in and color it all. The 3D printer does all that for you. And it comes out in an amazing quality. So there is a benefit to this type. And if it is what you want, please do get in touch with aic.aura@hull.ac.uk, and we will forward you on to the people who love this machine and use it every single day. So yeah, it's a great bit of kit. So yeah, this is called PolyJet 3D printing. It's for that finished look. It can be quite an expensive 3D print, but if you're going to an investor, you want to spend that money and get it done, or if it's for a certain application that requires a certain material, a certain rubber, a certain elasticity, this is the job for you. So it can do all sorts. So shoes, we've got a brain head. It can do all this intricate stuff. It's a great bit of kit. So again, that's something we offer here at the University of Hull, is it's very high-end bespoke products. So I think we're just going to go to another poll as well. So I just want to catch up with everyone, just check where they are. Would you be interested in either SLA or PolyJet 3D printing, or both? Did they pique your interest? And then, have you ever heard of 4D printing before this webinar? It's a weird question, but we are just about to go into the 4D printing section. So would you, as a business, as a client, would you be interested in either SLA or PolyJet 3D printing? I will just talk quickly about the background as well. So we've got the metal 3D printer over here. We've got the composite 3D printer, the FFF. Got our FDM printers, SLA and SLA 3D printers on this side of me. Yeah. Brilliant. So thank you very much for everyone who answered the poll. Would you be interested in SLA or PolyJet? All of you have said both. Everyone said both, which is great. So please do get in contact if you are interested in them. And then, have you ever heard of 4D printing before this webinar? We've got a split down the middle, 50-50. Have heard of it, and the other 50 haven't. So hopefully we can get you up to speed with what 4D printing is. So we've just got 5 minutes left. I'm just going to take you through a quick bit of 4D printing, and then we'll stop for questions and see where we're at. There we go. So I've previously done actually a webinar on 4D printing. It's available on YouTube. So please do check it out. It was done with the 3D crowd. So just going to talk briefly what 4D printing is, and how I describe it is actually time-dependent 3D printing. It's 3D printing with effects that continue beyond the print. So if you 3D print something, let's say I 3D print this dice, It's a dice, that's all it does. It sits here, it doesn't move, doesn't change properties, doesn't do anything. But if I printed it with a material that could react to sunlight and it would change shape over time, that would be time-dependent 3D printing. So time-dependent 3D printing has different variables or different things it can react to. It could be heat, light, water, electric current, magnetism. It could react to a chemical change. There's a lot that can interact with 4D printing. So yeah, if you're interested, please do go see my webinar. Who uses it? Loads of people: Adidas, Autodesk, NASA. I've actually got a pair of 4D printed shoes from Adidas, which are awesome. So as a quick rundown, we're just going to run off. So we've got SLA 3D printing. So this is where we 3D print our designs with this clear material, tough material, elastic material. We've got polyjet 3D printing for these high-end bespoke prints, which we can offer here at the University of Hull. And that is just me wrapping up. So what I want to say is actually all our webinars that we've done currently are on YouTube. So please do go and see them on YouTube. We'll be posting links as we do. We've got our 2 previous ones and our overview that we did 2 weeks ago on YouTube. So please do go check them out. Our next one is on Thursday with Jordan. So we're looking forward to that one. And then we've got another 3D printing one on Tuesday, 3D printing with metals. So you can join myself for that. And then we've got Jordan again for product validation. That's next week. And then the week after is another one. So yeah, please do join us. And if you miss it, just catch us on YouTube. And then I just want to say thank you. And just to open up the floor, if you've got any questions, or if there's any questions in the chat or in the Q&A, please do ask them. If you don't have a question right now, please do email us at aura.aic@hull.ac.uk or aic.aura@hull.ac.uk, sorry. Or go follow us on Twitter, or come and see our website as well. All details of future events are on our website under the events tab. So please do check us out. And we look forward to seeing you again in a future webinar. So any questions, Jordan?
No new questions have come through at the moment.
Okay, so yeah, we're nearly at 12 o'clock, so we'll be wrapping up. And yeah, I'm happy. So thank you very much for joining us. Thank you, Jordan.
Thank you.
And please do join us soon. Thank you.
Bye.